There we go. Bitrate's going up. We're not dropping that many frames. Okay. I'm okay with this. It's the projector. Yeah, that's annoying. Okay, so I can't project to this screen then. How can I fix this? One sec. Let me think. What's up, Nick? Yeah, cool. Just trying to figure out. What's up, Bob Ross? It's good to see you, dude. Give me 2 seconds. I'm just trying to figure out what I want to do to stop the render lag. I need to, because I want you guys on Discord to see this still too. But, yeah, it's my second video card is what's fucking up. It's trying to output to that one, and it's just like not happy. Let me think. I could cast this to this screen. Okay, but then I won't be able to see anything on Discord. Ooh, that's gonna be super annoying. Ugh. Okay. I will figure this out next time. For y'all in Discord, sorry, you're just gonna have to watch my main screen until I figure that out. It's unfortunate, but it's just how it works. It's okay. Oh, you know what I can do, actually? Give me a second. I think I can have the bot. No, but there would be a latency on it. Did it happen before? No, what happened was I updated my graphics drivers because NVIDIA, like, wants me to. But the problem is, like, for those that are technically involved here, I'm running a 3070 Ti to control, like, most of the screens. And then I have a second video card, which is like an AMD piece of shit, whatever, that is controlling the virtual displays, which is how I pipe stuff into Discord as well. And I think when NVIDIA came in, it like wiped out my AMD drivers, which is now messing up my ability to stream without any latency. It sucks. Yeah. Whatever. Okay, cool. Sorry, y'all on Discord are just gonna have to watch my main screen. And actually, I might start not streaming so much on Discord, to be honest, just because from a bandwidth point of view, like Discord takes a ton for me to cast my screen. And then I know the latency's good, but you know, I'm moving away from it. I think like Twitch is what we really want to be using for stuff. But okay, whatever. I'm just gonna cast this screen. Let's see if that increases a lot. I don't think that does. Okay, cool. All right. Yeah, so if you want to see my beautiful face, you got to watch on Twitch. Cool. All right, anyways, let's start off the stream. Welcome everyone to Office Hours. My name is Dr. Gold's Actual Education, the stream that helps you with math, homework, science homework, all types of fun stuff. You always have a phone for Discord chat, yeah, but I like having all my screens here. I have so many screens. Y'all have seen my setup. I'm sure you have. Like, I have a lot of screens. I guess the only disadvantage is like, yeah, all y'all on this are gonna see like everything I do. I can't do any behind the scenes stuff for you guys on Discord. You get like unfettered access to my display. NVIDIA drivers are update usually right, and AMD drivers too. Yeah, the issue is I'm running an NVIDIA card and an AMD card. I'm running both. And when you run both, when one driver updates, it tends to like try to kill off the other one, which is bad. So yeah, it's unfortunate, but it's just how it works. But yeah, if anyone wants to, this is my setup. This is how many screens I run in order to stream this to all you guys smoothly. Because I have to have OBS running on one, I have to have teaching on the other one, I gotta have Discord on the other one, and then we got like other chat stuff on the other stuff. So like, there's a lot of screens and stuff going on for this to work, which means I have to run 2 video cards. Because NVIDIA maxes out, I think, at 4 or 5. And this isn't even counting the virtual displays I have in order to make it so that Discord can show what's happening on Twitch as well. Yeah. It's a little complicated. It's cool. It's like a work in progress. I mean, again, someone was like telling me, like, hey, I want to get into streaming. I'm like, cool, yeah, dope, do it. Oh, yes. But getting to like this level of what I do takes years. There's a lot of finicky stuff you have to figure out with trial and error, honestly, to get stuff to work. But yeah, I'm glad. I'm getting no skipped frames doing the rendering lag. Okay, so now I know it was the external display which was screwing things up. Okay. That's all right. We'll fix it. Anyways, okay. Happy birthday to Bob, by the way. Come on up here, Bob. Dude, it's your birthday, dude. What's up, dude?
Not much.
Happy birthday, man, dude. That's dope. First birthday in college, yeah? First college birthday?
Yeah.
Wow. I remember my first college birthday. What are you doing? What are you doing, Bob? What's special? Are you doing anything special for your birthday?
No, I'm not.
Yeah, he's like, it is Wednesday, right? Wednesday's kind of a weird day
Yeah.
to celebrate your birthday because you're like middle of the week right now. Yeah.
Yeah.
It's all good. It's all good. You'll do something over the weekend, I'm sure, right? Y'all gonna? Well, you can't do anything, dude. It's pouring right now. Is it pouring where you're at USC? Is it pouring?
Yeah. I didn't even expect it to this morning. Like I got out of class at like 12,
Uh huh.
and then I didn't expect it to pour, so I didn't even bring an umbrella or anything.
Oh,
I
no.
just got soaked.
Oh no. Yeah. Yeah, I went to the gym earlier and I saw the clouds and I was like, that don't look good. So I brought my car and luckily I did, yeah. Usually I walk to the gym, it's like 2 minutes for me. But I brought my car and yeah, it was starting to pour down a bit. And then it started like dumping, dude, like an hour ago. And I was like, oh man.
Oh yeah.
It is bad. It's bad. No,
I haven't got wet like that in a long time.
Oh fuck. Okay. All right. Well, hopefully drying off for the rest of your birthday, Someone should like get you a cake or something, right?
Maybe.
Yeah. Equity says you got a 6-pack gold. What do you mean? Do I got a 6-pack? Like a 6-pack of beer or like a 6-pack of abs? I used to have a 6-pack of abs. That's hard. 6-packs are hard. You have to like starve yourself, unfortunately, or have like really good genetics. I've done it at some points, but it's not sustainable. Abs, yeah. No, I have. Yeah, I'm sure you have my Instagram Equity. You can go through all my fitness pics. I've had varying degrees of fitness. I'm at like what's more of like a stable thing here right now, where like it's kind of more like athletic dad bod, which I'm cool with because at least I can think. When I was like super ripped and super 6-packy, whatever, like I couldn't think because you're having to starve yourself of calories and you can't do things. That's why all the models are fucking dumb. No, because they starve themselves. Anyways, Bob, let's do your question. Little birthday present. I'll do you do yours first, right? Yeah.
This one seems very hard. Oh man.
For real, cutting sucks. It does, Equity. Yeah. All right. Let B of n be a sequence of positive numbers that converges to 1/2. Okay. Determine whether the given series is absolutely convergent. Oh, okay. Oh, okay. Okay. Given that, B of n goes to 1/2. Okay.
Yeah.
Oh, and it's a sequence. Oh, okay. So this is the absolute convergence test, right? What does that say?
Yeah.
I feel like
Or the convergence is
yeah,
normal and absolute value convergence, I think.
the absolute value converges. Yes.
Yeah. And normal convergence.
Dude, what is this, dude? Is B1 times B2 times B3 to dude, what? All the way to B to the end, dude? What's going on here, dude? Okay, okay. 40 you need help with 41. Okay. So 41 does oscillate, right? This definitely oscillates, right?
Uh-huh.
So this alternates between -1 and 1, right? And then B to the n. So this is less than 1, so this is going down, right? And then this is going up, which is going to make the so I believe everything's decreasing, right?
Wait, how do you know B of n is going down?
Because it converges to 1/2, right?
Uh-huh. Yeah.
Which
So
means
it's making everything cut in half.
Well, it eventually goes to 1/2, right? Which means it's a number less than 1. And if we're taking the nth power of that just makes it even smaller, right?
Uh-huh. Yeah.
So, right. There's also like what's it called, like the alternating series test?
Yeah, there's alternating series tests.
Which I mean, that's how we can prove that this is convergent. But absolutely convergent means I don't consider the alternating part, right? Because with the absolute value, now it no longer alternates, right? The issue is this. Like, this is going to keep bouncing around. But what's going to happen with the other stuff? Do we want to, like, do the limit comparison test for this? 1 second.
Let me see.
Let me see. I can figure it out. Where's my math backup, dude? Where are my math backup guys, dude? Where are you? Where's Zach and Penn Center? It's funny because now we're starting. Remember, I told you how like once we get to sequences and series, stuff is gonna start getting hard.
Yeah.
Yeah, that's what this is. We start like hitting the like. I have to start remembering calculus. I usually get to just like chill out and be like, it's all the same shit. Okay, I see. Okay. They do the ratio test for this one is what they do. And the reason you do that one, anytime you see stuff with factorials, Bob, right? Ratio test. Probably gonna be the ratio test. But yeah, this one with alternating stuff. I feel like this is a limit comparison test. Let me see what they do. By the Dirichlet series, like chill out, dog. Okay. Sequence.
Wait, there's no factorials in this one.
No, there isn't. Let b of n to the n sequence at partial sums is bounded. Let that is monotonically decreasing and converges in 0. I don't agree with someone else doesn't agree with this proof either. I don't agree with theirs either. Yeah. Good old Shag. I always like to see like what other people are doing, but yeah, the one on the right is easy. Yeah, that one is that you can just do with the ratio test. But let's see with this one. Okay, here we go. Okay. Okay. So they replace this. This is actually kind of cool here. Okay. So cosine of n pi, right, Bob?
Yeah.
That's the same thing as -1 to the n. Because if you're doing like cosine of multiples of pi, right? It's either 1, -1, 1, -1, right? Because it's pi, 2 pi, 3 pi, 4 pi, right? Okay, so I can just rewrite that right off the bat. So let's rewrite that as something that's like just definitely like alternating, but with it's quantized, right? Okay, cool. I like that. All right, we're getting closer. All right. Oh, I see. I kind of see what they're doing here. Okay. N to the 1 over n. What do they do? Oh, wow. They use the root test. Oh, man. Dude, I never use the root test. They use the root test. Yeah, dude. You know what it is? It's because of this. Anytime you see something to the n power, right?
Oh, to the n, yeah.
Yeah, you're probably going to use the root test, okay? So here's what they say. They say, okay, let's let a sub n equal to b sub n to the n -1 to the n over n, okay? And then I'm going to consider what happens, right, as n goes to infinity, right? So let's say the limit as n approaches infinity, but let's do it of the absolute value of a to the n to the 1 over n. So watch what happens here. So this ends up being the limit as n approaches infinity of b sub n to the n -1 to the n over n all to the 1 over n, right? Which, now that 1 over n is going to kill a bunch of stuff, right? This is going to go away. Well, the -1, okay, well, here's the thing. If we do the absolute value, right? Absolute value of this, that gets rid of this, so we don't need this anymore, right? So now we're just left with the limit as n approaches infinity of b sub n to the n over n all to the 1 over n. Okay? Which now I can distribute, right, the 1 over n. So now this is limit as n approaches infinity of b sub n to the n times 1 over n, which is just 1, right?
Yes.
And then this is over n to the 1 over n. Okay? And that's still what we've done here, right? We've done it to the 1 over n power. Okay. Which, whatever, absolute value, this will never be negative, right? Because you don't need to keep talking about the absolute value at this point for the bottom, because anything to an exponential can't become negative. And okay, so now we can split this into two limits, right? So this is the limit as n approaches infinity of b sub n all over the limit as n approaches infinity of n to the 1 over n. Now, we know what the limit as n approaches infinity of b to the n is, right? What's that?
Yeah.
That's 1/2.
Yeah.
Right? Because that's what was said way up here, right? Okay, cool. And then the other little bit of trickiness here is this is an identity where this technically goes to 1. So the limit as n approaches infinity of n to the 1 over n is 1. You have to know that one.
It's just an identity.
It's an identity. You're just supposed to know it. In the same way that, like, right, limit of 1 plus e to the x to the 1 over n, right? Or 1 plus 1 over n to the 1 over n is like e to the x. Do you know that one as well?
Yeah. Yeah.
It's just another one you're supposed to know. Because this is infinity to, it basically becomes like infinity to the 0, right? Which is
okay. Yeah.
I know that's like a hand wavy like bullshit excuse for it, but you know it's usually kind of what it is. Okay, cool. Okay, so now I know that the limit as n approaches infinity of my a sub n to the 1 over n is just equal to 1/2, right?
Yeah.
Okay. And then I guess by the root test, because this is less than 1, then this means it converges.
Yeah.
Is that how the root test works? Okay.
Yeah, that's root test.
Yeah. Dude, I never use the root test. I really don't, honestly. Let's look at 1 second. Let me get a full definition.
Root test. Hold on. Let me see.
Root test.
I don't know if it's 1 or 0.
No, it's this. It's this. This is what it is. Yeah. Okay.
Oh, okay. Oh, so then it's absolute conversion.
Yeah. Do you see this? Do you see how okay? Yeah. So we took our thing, right? We make believed it to the 1 over n, right?
Yeah.
And then we took the limit, and then we got that it was less than 1. So since it's less 1, it's absolutely convergent. Yes, that's the solution. Okay. Yeah. So I guess just a little heads up, just in case you see this a type of question like this again, Bob. If you ever see stuff with factorials, okay, do the ratio test. If you see something which is being raised to the power of n or has any sort of like n in the exponents, do the root test. Yes, because doing it to the nth root will kill off this thing, which is what you want.
Yeah.
Yeah, cool. Does that make more sense?
Why does root test work? Like yours.
Yeah, why does it work?
You're just basically taking off the exponent, right?
Yeah.
Basically just eliminating it.
Yes, I never use the root test, so like I don't exactly know why it works, but it does. Its proof is similar to proving the ratio test, I guess is what they say. Okay.
Just out of curiosity, can you prove the chain rule?
Prove the chain rule? What do you mean prove the chain rule? Yeah, that's easy.
Can you?
What proving the that's easy. Can? Oh yeah, that's super easy. Yeah, what? Yeah. Well, that's just like df dx is equal to df dA times dA dx. That's all that is.
Yeah.
Do you know that proof? Do you know that one?
No, I don't know proof.
Oh, okay. Well, let's say for instance f is equal to cosine of x squared, right?
Yeah. So it's 2x times negative sine of x squared.
Well, yeah. So it's negative sine of x squared times 2x. I'll show you where that comes from. Okay. Yeah. So what I do is I say let x squared equal to a, right? So now I have the cosine of a, right?
Yeah.
So now if I want df dx, right, that's equal to df dA, right? So now f is equal to the cosine of a. So the derivative of this with respect to a is just negative sine of a, right?
Yeah.
And then the derivative of dA dx, right, is just the derivative of this. So this is d dx of x squared. That's just 2x. Okay, and so that's where that comes from.
Okay, can you use definition of derivative to prove it?
Like the limit definition of a derivative?
Yeah.
I mean, probably. I don't want to.
Because I asked my friend if he could do, and he was like, no.
That's a good question for our other math streamers, honestly. Yeah, I mean, again, my level of math is like let's make sure you do well in your class and get good grades and stuff. Hypatia probably knows. Hypatia's the heavy artillery. Hypatia, do you know how to prove the chain rule with a limit definition of a derivative? Is that possible?
Yeah, yeah. Let me see.
Cool.
I can't write up like I can write up a proof, or I can just screenshot a textbook for you.
Just
Let me
just
do
screenshot.
that.
Yeah, just screenshot something for me so I can, and then maybe we can walk through it real quick. You know, because Bob's got to go. And what you got? Oh, you got an hour, right, Bob?
Yeah, I know.
All right, you got time.
I'm on my phone. Sorry for the wait.
No, you're okay. You're okay, dude. You're okay. Nice. Yeah, I was about to say, like, yeah, because my level of math tops out, but then Hypatia goes beyond. Hypatia goes into the fundamental of, like, where does this come from?
Let me see. I can't search the text, so I have to which chapter derivative. Page 103. Okay.
Yeah, here, I'll let you find it. We'll go through
Page
the other questions we have today.
103. Yeah, in the meantime, look at the joke I sent you.
You sent me a joke. Did you DM it to me? Oh, you put it in office hours?
Yeah.
Okay, let me see it. I'm gonna put it up. One sec.
I think, well, you are not an astrophysicist, but you might still be.
I'm not a super astrophysicist. Fusion burn 3s. Hey, wait, is this what they say when the rockets are going off? Do they say this stuff?
No, this is Chonibyo. Do you know what Chonibyo means?
No, I don't. This is some high level jokery.
Chunibyo. Search for it.
All right. What is it called? How do I spell it again?
Chonibyo. Chunibyu.
Chuni. Oh, I got CHUNIDEU.
BYU.
DYU. Oh, ooh, cool.
BYU.
Dude, Chunibu. Okay. Chunibu, this right here, okay, is a Japanese colloquial term used to describe early teens who have grandiose delusions, who desperately want to stand out, and who have convinced themselves that they have hidden knowledge or secret powers. They call it middle second syndrome? Wow.
It's based on an anime about.
Oh, I mean, these kids love anime. Yeah, that's cool. Has anyone anyone in the stream? Do y'all know this anime? Do you guys know this one?
And so KSP is a space game. It's about like launching rockets.
Oh yeah, Kerbal Space Program. I know that one. Yeah. Yes. I know Kerbal Space Program. Was it Kerbal?
Okay, I got a screenshot, I think.
All right, nice. Send it up. I'll go to it. Yeah. Oh, that's how you spell it. It's Kerbal. Yeah, this. My one friend in grad school was super obsessed with this. Like, he really wanted to like go to the moon and shit, and he ended up dropping out of grad school because he was so obsessed with going to the moon or like going to Mars. Sorry, he wanted to go to Mars.
NASA? I mean, you don't need a PhD to join NASA. They are
well,
engineers.
he wanted to join SpaceX, and then it became like kind of like rough for him because his girlfriend ended up getting a job at SpaceX, and then they broke up, and then there was like resentment. It was like a whole thing.
I got you. The screenshot.
Got you. Yeah, let me pull it in. Okay. Ooh, here's a good. All right, we're gonna go through this, Hypatia. I love like trying to understand math proofs.
Yeah, but the joke is that so basically.
What's the joke here? Sorry.
Basically, have you ever seen like Navy ships, especially Imperial Japanese Navy ships, like in the films, they will shout out these kind of things.
Probably, yeah. It was like little military things they shout out.
Captain will shout out the first sentence, and then there is another first officer shouting out the second sentence.
Okay.
So this is well.
Okay, that's cool. I like it.
Iota transfer means injection transfer. It's just basically you're returning from Mars to Earth. Tango Gaia means transfer to Earth.
Oh, Gaia is named Earth, right? Isn't that a whole thing called like Gaia Online? Isn't that like some anime y'all watch?
Well, Gaia is Roman's name for the Earth. Like, for example, you see space shows where they call the moon of Earth as Luna.
Yeah.
Yeah, and Fusion Burn 3, that's a naval thing, like Forward 3. That's a
yeah. It sounds like a naval thing.
To regulate the engine, and then burning sunward. Everybody brace for 1G acceleration.
Oh, that's cool. I like that. That's cool. Nice. All right, let's see. The following theorem is known as the chain rule. It deals with differentiation. Okay, suppose f is continuous. Yeah, I know what the definition is. Okay, let's prove it, though. Okay, so by the definition of a derivative, yes, we have, okay, let's see. Well, let y equal f of x. By this definition of derivative, we have, okay, this is the standard definition, I guess. Wait, where is this coming from? T minus x. Is this the linear approximation is what it is? Wait,
Which one?
Right here. Just when we get to here, by the definition of the derivative, it says f of t minus f of x is t minus x. I get that. That's like the delta x term, right? Times the derivative. But then they say plus this u of t. Okay.
It's the linear approximation, but in this case, you are actually trying to define a function called u. That depends on this fixed point of x, such that for every t you moving around.
Yes.
Like you can write down the definition of u directly, explicitly, with some algebraic manipulations.
Yeah, I see.
Yeah, so it's for g and v.
Ah, okay, I see. Okay, g and v are other things. Yes, okay. And then they say where t is contained in a of b, s is contained in all imaginary numbers, u of t goes to 0 as t approaches x. Okay. And as s approaches y. Okay, so these things go away, right? Okay, I get that. And then let s equal...
Well, they don't really go away, but they like when you push the limit towards that point, it goes to 0.
Mm-hmm.
By letting t goes to x, we see that s goes to y. Well, that's not quite rigorous, but you can go with it. So kind of s is also a function.
Yes. Okay.
S is also a function of t, and then by the continuity.
Oh, okay.
Of
I see. H is g of f of t. Okay. So h of t is g of f of t.
Yeah.
H of x is g of f of x.
Is h prime, which is just the derivative of the composition, while the right side is g prime y times f prime f x.
I see. Yeah, no. Yeah, you're right. Good. Yeah, this is just
the y here is actually just s of.
Wait, but we're missing the s we're missing s minus y though. Where's s minus y? I see the t minus x for this part, right? I see that. But g of
y here is just like f of x, and then s is just another function depending on t. You can think of it that way.
Oh, okay.
Or
let me see. Someone in the chat, Udell Not Labin says, I really want to learn the nitty-gritty math, but it's tough to learn via YouTube videos and books.
Yeah, actually, this proof is badly written. I think the notation is very confusing.
Thank you, Euler. So Udell says, "What is that the best method? Just to suck it up for those 12-hour courses on YouTube? That's so tedious." Yeah, I agree. That kind of sucks. Hypatia, what would you recommend to someone who wants to learn more of this? They want to learn more of like the nitty-gritty of math. How would you recommend that they learn it?
Book, I guess.
Just read
this book, I guess.
Just read books.
This is Rudin. It's a quite old but classical book, like the Rudin trilogy. Mathematical
What's it called?
Analysis,
What's it called?
Walter Rudin. The author is WalterRudin. Walter Rudin.
Principles of Mathematical Analysis. This is the book you recommend?
There are 3 books. This screenshot is from the first one. The second one is about measure theory and complex variables, and the third one is about they call it functional analysis, but I think Rudin tried to cover more.
Okay.
Like much more than it.
Yeah.
Topological vector spaces. I don't know.
This goes into a lot. Yeah. No, there's a lot here. Yeah. So okay, to our viewer who was asking, yes. Start here before algebra and calculus. Well, okay, yeah. How much math do you know already? You probably should learn the basics. You should learn algebra. You should learn calculus. Because this stuff kind of goes in. Well, you said the nitty gritty. So this is like the underlying framework behind why algebra and calculus work. So I don't know if it's. Do you think it's necessary, Hypatia? Do you think people have to take calculus and algebra before they can go through a book like this, like a mathematical analysis book? You didn't, right?
I didn't.
Yeah, Hypatia didn't.
Yeah.
Yeah, so if you want, like, here, the PDF is free. That's a good one. Another good person.
My experience isn't really the most typical one, because not everybody have a. My experience, my history is quite extraordinary. It doesn't offer any guidance to anyone.
I see. Yeah. It's yeah. Well, okay. So Udell, if you really want to know, what? Let me see. EXP2i Pi. Yeah, there we go. That's his. That's a really cool other math streamer who does more kind of fundamental stuff. Let me see if I can do a shout out for him actually like this. Let me see. Shout out, and then let's do that. Let's see if it'll do it. Does it do that? Yeah, there we go. Okay, cool. There's a shout out for his channel. So this guy, he's another one of our friends who does math streams, and he's doing a whole mathematical analysis class on Twitch. I think he's wrapping it up in the next week or two, but then another one of our friends called Penn Center is going to be doing a complex analysis class. So if you want to participate in more of like a live setting, these guys are doing some awesome streams. And it's much better than just sitting in front of YouTube and watching some guy just go blah, 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 blah. You know, like that's really boring, right? You can actually participate in these with these people, and if you ever get stuck or confused or stuff, you can ask questions, and they will break it down. I know at least with Zach here, he's E to the Pi I. His whole mathematical analysis class was built around it being more Socratic, so he would give out PDFs of like, here's what we're going to go over this week in these lessons, try to do these questions, and we're going to go through and work them out together on the stream. And he does them for a while. You know, this is a 3.5 hour stream he had here for day 18, I guess. And so this is him going through a real analysis set of questions, and you can participate in it and stuff. I know this is wrapping up in a week or two, but the other person who's very cool is Penn Center. So here, I'm just going to give you all the math streamers. Those are all our math streamer friends. But yeah, Penn Center is going to be doing a complex analysis class, I think, during the summer. So hang around on Twitch, you know, follow all these guys on their channels. And if you just lurk around, ask questions, they're more than happy to help you out with stuff. And we have a wealth of other, you know, really awesome, smart math people like Hypatia. So if you have any high-level stuff, join our Discord. There's our Discord. And you can DM people like Hypatia, and I'm sure they'd be more than happy to kind of point you in the direction of, like, where you should be doing stuff to learn more math. Yeah. Cool. I appreciate.
You can play KSP with your students and other audiences. It will be cool.
I should do this. I should do like a Kerbal Space program, like.
But right now, I think it's $50-$60 because it's early, like an early version.
Oh, I don't mind paying for it. I don't mind paying for it. That's okay. But yeah, this would be fun.
Yeah, it's cool. You learn actual
astrophysics and stuff. You learn physics
actual stuff? orbital thing.
Okay. Yeah, there's a lot of orbital dynamics, a lot of Newton's laws, Kepler's laws. A lot of Kepler's laws is what it is, right? Yeah.
I think it's more right now. You can all the laws are derived with Lagrangian analytical mechanics.
Okay, but, so not like super complicated.
There are also software packages telling you how, for example, say my orbiter is over Mars and now I want to go to Earth.
Sure.
What do I do?
Yeah, what do I do?
That's what the burning sun was, because there has to be a window where Mars and Earth are the closest, and then you burn
and then it works. Yeah.
Well, not really pointing toward the sun, but just there is a specific angle, specific vector that you burn towards.
Yeah, in order to push the velocity that direction.
Amount of time, and then you go to a transfer orbit, and then you flip your vessel when you are close to Earth, and then you deaccelerate so that you actually
Yeah, you don't like splat.
So that you will be captured by Earth's gravity and enter a rotating orbit.
Y'all know about that? What was it called? That that lander that we sent to Mars that got screwed up because they put the wrong units in on the code, right? They used like inches instead of centimeters. What was that one called? Mars.
Oh shit, that's bad.
Yeah, it was so bad, dude. It was so bad. It was really bad. Well, it was a Mars rover miss.
Sovereign United States never wanting to change billions.
It was from a metric error. This was it. Yeah, NASA lost a spacecraft due to a metric math mistake, bro. What? So after 10 months, they're expecting to celebrate because they didn't use the right units. So yeah, if you want to read about this is this millions of dollars, if not billions in today's money. They screwed up because they were using inches and stuff instead of centimeters. So yeah, if you ever want to learn about like why units are important, that's why. All right, equity here. Let's do your question. I gotta run through some questions because I gotta bounce in like 40 minutes. But yeah, there's the link to the textbook, the Rudin textbook that Hypatia gave. If you want to check that out, go at it. What's up? Where's equity? Is equity here? Let's see where equity's at. Equity always has these fun little math puzzle questions. Love these puzzles. Puzzles. Yes, sir. Okay, here we go. A numerical value is assigned to each letter of the alphabet. Okay, it's like a cipher. It's like a code. The value of a word is determined by adding up the numerical values of each of its letters. The value of set is 2. The value of hat is 7. And the value of taste is 3. The value of mat is 4. What is the value of the word math? Okay, that's cool. I think this is going to be like just a big linear algebra question, right? I'm just going to assign variables to everything, right? So let's do this. So m is equal to x. A is equal... Well, actually, you know what? I can just use the letters. Yeah, fuck that. Let's just use the letters. But I need an ordering to it is what I do. Yeah, let's have an ordering to it. At least like what's first, second, third, right? So I know m plus a plus t plus h is equal to question mark, okay? That's what we're trying to figure out. S plus E plus T is equal to 2, right? Hat is equal to 7. Taste is equal to 3. And mat is equal to 4. Okay. So, what's up, Waffle Walrus? Good to see you, brother. Yeah, so what would be cool here is if there's some combination equity of these things, like maybe 2 of these minus 1 of these plus like 3 of these gets me math. So, let's kind of see if that happens, right? I can kind of already see it just because okay, look. So, this almost gets us to here, right? MAT, right, is equal to 4. But I need to know what MATH is equal to. So my missing thing is H, right? Which means that if I want to figure out H, the only other way I can figure out H is from here. And that requires knowing what A and T are, right? And then A and T show up here, but then I need to know SE and T. Oh, but SE and T. Look at this. Actually, this is very cool how this is going to work. This is a puzzle. Yeah, watch. Okay. So again, big picture is I saw math. I was like, cool. I already got MAT. Let's find H. H is here. I need AT. Where's AT? AT is here. But now I need SET. SAT is here. So right off the bat, okay, I see here, right, taste, STE, has the same letters as set. But set is equal to 2. This way this is going is making my brain happy. Agree, dude. Yes, I'm very happy with this. Yeah, because this looks like there's a logical progression to this. Yeah, it's awesome. Yeah. Okay. So set, right, which is right here, that's equal to 2, okay? So now I know that T plus A plus 2, right? Or let's use a different color, right? Is equal to 3, okay? That's awesome. Because that automatically tells me, right? That tells me what T plus A is, right? So now T plus A is equal to 1, right? T plus A is equal to 1. If we move this over, look where T plus A shows up. It shows up in hat. Right? I know that this is 1. So now H plus 1 is equal to 7. That tells me H is equal to 6. Just right off the bat from that, right? And now H is the only thing missing from Matt. So if Matt is 4, H is 6, that means math is equal to 10. Wow. That's a cool one.
That's dope.
Yeah, that's a fun question. It's always 10. Yeah. I thought that was going to be harder. They were all combinations of each other. Sometimes it's like you need multiples of them. Like that's where that would get harder, but they didn't do that too. Nice, Equity. If I have more time, Equity, I'll do the other ones you posted. But let me run through everyone real quick. Ethan, determine the vector field is conservative. What? What? Excuse me? Ethan, do you even know what this is, dog? Man, determine if the vector field is what? Is conservative. I think what that means is that like nabla squared f is equal to 0. Is that what like a conservative vector field is? I gotta look this up. Conservative vector field test. Okay. Oh, what is it? What is it? Yeah. Okay. Here we go. F equals what? Okay. What? Where do I test it? If f equals nabla f, any part. That's what they're saying. Oh, okay. Here we go. A vector field is conservative if dp dy equals dq dx. Okay, this is cool. Has to do with partial derivatives. I knew it was something like this. This goes back to like, this is a physics thing. But okay, this is the rule. And luckily this is only 2 variables. Okay. So I'm going to call, and this is good because this is a lot of partial derivatives. The entire subject of mathematics is equal to 10. Yeah, I believe it. Okay. Let's call this whole thing here. Let's call this P, right? And then let's call this whole thing equal, let's use a different color. Let's use green. Let's call this whole thing equal to Q. Okay. So, what I'm going to do is see if the derivative of one thing with respect to one variable is equal to the derivative of the other thing with respect to the other variable. Okay. So, partial P, partial Y. That means when we take derivatives here, we only consider things that have y's in them as things we take derivatives of, okay? So x cubed does not have a y in it. Means the derivative of that thing is 0. It's a constant. This, however, does, right? This has a y right here. So the partial derivative of minus 4xy squared is only considering this thing to be the thing we take derivatives of. So this is considered a constant, just a number. And the partial of y squared is just 2y, right? So this is going to end up becoming negative 8y. And then the derivative of 2, that's a constant, 0. Cool. Okay, now we have partial q, partial x. Partial q, partial x, so that's equal to 6 right here. And then that's also going to be plus 3x squared. 3x squared, what is this? It's 3x squared minus, no, 3x squared y cubed is what that is. Okay, cool. Okay. Partial x is 1. Now here's the issue, because now this, I have like x's and y's in here, right? I don't have just like nice numbers. Okay. Maybe is there a way for these two things to equal each other, I guess, is what we say. Is it conservative? I think that's how that works. Let's see. Okay. One sec. There exists a potential function such that grad f is equal to f. Okay. Such that df dx equals f1 is that. Okay. equals 2xy minus sine z. Oh, okay. I think I see it.
Hello.
What's up, Ethan? Yeah, this is a tricky question.
Okay.
So fxyz is x
You
squared.
gonna help me with a question today?
I'm trying to help myself with it because I haven't done conservative vector fields in a while.
Oh dang.
Yeah, it's
Hopefully
tricky.
you'll learn it.
Well, Ethan, you should pick like Calc 1 questions, bro. You haven't even taken calculus. Like jumping straight to calculus 3 is a lot. Especially like even for myself.
Honestly, I could take it though. Like I've already done derivatives, and that's half of the
Yeah,
subjects.
no, but that's no. You've learned the power rule for derivatives, which is the easiest part of calculus. You haven't even gotten to like the real meat of stuff. Yeah.
I mean, that's the easiest part of calculus.
It is the easiest part of calculus. Yeah, the power rule. Power rule is like chump change, dude. Yeah, doing this stuff is like a lot harder.
Oh wait, that calculus tree question that calculus tree question I didn't that also involve the power rule for
Well, it involves partial
like, for
derivatives.
answer?
Involves partial derivatives, and like also involves you like knowing what like grad is. Like this is vector calculus, Ethan. Like you have not done this. And even if you were a calc 1 student, you wouldn't have done this. This is multivariable calculus is what this is. It's a lot. Again, it's not too difficult, but it's way you're skipping way too many chapters. There's so many other things beforehand you're supposed to know.
Okay then. Why don't I just give you an easy calculus 1 question?
Well,
I don't know.
I kind of like
Let's go.
trying to do this one, but
Can we do it?
do what? Do the one that I'm trying to do?
Like, can I ask you like a calculus 1 question?
Yes, you can ask me a calculus 1 question. Yes, because doing calc 3 like right off the get go, this is a little tricky. I gotta remember like wait if f p of u is a conservative vector field and p and q of continuous blah 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 to a statement with okay yeah, but what happens
I wanna ask you something.
what happens when the but they're not first order. That's the issue. One sec. Yeah.
But I want to ask you something.
What do you want to ask me, dog?
You know what are logarithms?
Yes, I know what logarithms are.
Can you do those without calculators? I've never done logs before.
Yeah, you can totally do logarithms without calculators. What? Yeah, here. Let me just teach you logarithms instead of doing like conservative vector fields.
Oh, look, I'm trying to find actually like calculus 1 question.
No, God, please, no.
Okay, here.
you just
I'm
wanna
gonna
teach me
teach you log rules. Log rules are better. Okay, because that's more your pay grade, dude. You're not in college yet, so let's chill. Okay. All right. Let's say, for instance, I have the log base a of b is equal to c. Have you ever seen this before?
No, I've never done logs. Okay.
Okay.
I've never been taught logs as yet.
Okay, well, I'm going to teach them to you right now, real quick. Okay. Whenever you see something like this, what this means is this is a to the c is equal to b. That's the rule.
What? That doesn't even make any sense. What?
I know it doesn't make sense because you've never seen it before, Ethan. They're called logs. So, a
What?
to the c is equal to b. That's what it is. Okay. That's
Wait,
what this
isn't
translates
supposed to be
into.
negative?
No, there's no negative. Okay. Let's look for example
Because
here.
the c is
If I have log base 2 of 8 is equal to something, you should be able to solve this. Okay. How would I solve that using this?
Wait, isn't the thing unknown then?
This thing is unknown, right? Cool. Yeah. All right. We can replace this with C. That's cool. What do we do next?
Okay. So I think isn't it just like 2 to the c power is equal to 8?
Yes. Good.
Something like that.
Nice.
Yes. 2 to the C is equal to 8.
So what?
Do you know how to solve
So
this now?
what's that supposed to do?
Well, solve for C.
No.
2 to the what gets you 8?
Hold on.
2. It is. Good. 2 times 2 times 2 is equal to 8, right? See how this is 4 and then that is 8, right? Good job.
Okay, I see.
Very nice.
So, there are some rules we can learn about logarithms that can actually make this easier, which are pretty cool. I'm going to teach you some of the rules. All right. One of the rules is if I have the log base a of a, this is equal to 1. Let's see why that makes sense. Watch.
Let me guess. Isn't it the same thing as like the power to 0 rule?
Kind of. Okay, but look here. If I have the log base 2 of 2, right, is equal to something, let's replace that something with c. Do you see how this becomes 2 to the c is equal to 2?
Yeah, and it's just 2 to the 1, right?
2 to the 1, right? Yeah. So that's an important rule. Anytime you have the log base something of the same number, that just equals 1. Okay? Cool. Good rule to know. The other rule you learn is the log base a of b to the c is equal to c times the log base a of b.
What is all that garbage there? What?
Yeah, I know. There's a lot. It basically says anytime you have an exponent inside your log, you can pull it outside as a multiplier. So, for example, if I had the log base 2 of 2 to the 3rd, okay, you can take this exponent and you can put it out front. Okay?
All right.
Anytime you're taking the log of something and it has an exponent, the exponent can come outside the log. All right? Now look what happens here, right? So this let's go back to like what our original example was, right? So I had the log base 2 of 8, right? Another way to write 8 is as 2 to the 3rd, right?
Yeah.
And then another way to put 2 to the 3rd when 2 to the 3rd is inside the log is to take it out, right? So do you see how this becomes 3 log base 2 of 2? And then what did we say the log base 2 of 2 was equal to?
1.
1. See how this goes away? This is just 1. And you see how the answer is 3?
3. Yeah.
Which, right? That's the same thing you figured out here, right? You figured out that that c was equal to 3. Right? Because this was 2 to the c is equal to 8. Yeah, that's why that rule is like self-consistent.
All right.
Okay. So that's a cool rule to know. The other good log rule to know is, so if you start just ignoring the bases, let's say we have the log of a times b. This is the same thing as the log of a plus the log of b. Okay?
Okay.
And if I have the log of a divided by b.
Is it the log of a minus b?
Yes. Do you want to see why that is? It's pretty cool. Okay. What's another way to write a divided by b if I wanted to multiply things?
What? That didn't even make sense. What?
If I want to write two numbers dividing by each other, let's say I want to say 3 divided by 4, how can I write that as 3 times something?
Why don't you just write 3 times 4?
No, that would be 12. I could say 3 times 1/4, right? You see how 3/4 is 3 times 1/4?
Okay.
Does that make sense?
That.
It does? Yeah, okay.
Yeah.
So this is the same thing as the log of a times 1 over b, right? Which, let's remember, what happens when I have the log of two things multiplying by each other?
They're adding.
Good. So this is the log of a plus the log of 1 over b, okay? Another little bit of information here. What is 1 over b as an exponent?
I think isn't it just b to the -1?
Exactly, dude. Yes. So now this is equal to log of a plus log of b to the -1, okay? And then what do we know about the rules of log of something to a power?
What?
What happens?
The rules of what?
What happens to the power?
All right, they go to the left side, right?
Good. So this power here comes out front, right? And now I have log of a plus -1 times the log of b, but plus -1 times, right? This is just going to be minus, right?
All right.
Do you see
Alright.
how that, right, is the same rule as this?
Yes.
Yes, and that's how it works. Cool?
All right.
Nice, good job.
Yes. Why can't they just learn calculus 3 already?
Because we got to teach you how to crawl before you can run, dude. That's why.
I already know how to run though. I don't need to crawl.
You don't. Yeah. I appreciate the
Wait,
I appreciate the enthusiasm. But you have to like actually go through calculus 1, because if I start trying to teach you calculus 3, there are too many other things you don't know yet that will become just a pain to like try to re-explain. You want to go through the calculus things in order. It's not like history, bro. Yeah, I know. In history class, you can take American history and then world history and then like history of the Greeks or like, I don't know, ancient Egyptian history. It doesn't really matter what order you take the classes in, because they don't really like, they're not like sequels to each other. I mean, they are in time, but not like, you know, in terms of history stuff. But math builds on itself. You can't skip things in math. You have to do them in order, because everything in math, at least in the middle school and high school level of courses, builds upon what you learned in the previous course. So
All
you
right.
can't skip to the ending. What's up?
Tomorrow I have like how do I say it? A test for one of my computer course classes.
Mm-hmm.
And I want to ask you, do you know what's a GUI?
Yeah, GUI, graphical user interface.
Yeah. Do you know the definition of that? I want to ask you that. I know the definition.
It's something that has like, I don't know, like screens and buttons and shit. It's kind of what it is. That's how I describe it.
What? Yeah, that's true. I mean, it does contain what is called widgets.
Widgets. Yeah, I guess that's a cool thing. Widgets. What's up? We got Saint. Half Alpha's got a question too.
All right, well, I gotta go now.
All right, good to see you, dude.
That's dope.
All right, that's Saints. That's that. Okay, Saint or Half Alpha, if either of you are here. Saint's here. Awesome. Let's do yours. Cool. And then Josue, I'll get to you, man. I don't know if your audio's working. Yeah, I don't know. It's okay. Can you hear me at least, Saint? That's all that matters, as long as you can hear me. If you want to join the stage and talk, we can test. We can test your mic, see if your mic works. It's okay. I'll figure it out. Yeah, okay. Yeah, this is good. So we're adding, they call them rational, I think they're called rational functions, not rational fractions. Rational and fractions is kind of like the same word. Like, I think the word like rational when it comes to this stuff, this means like ratio, which is like fraction. Not like rational numbers, that's a different thing. You're on Twitch? Cool. All right, good to see you, Saint. All right. Yeah, so I want these two things to have the same denominator. In the same way, if I wanted to do like a quarter minus a third, I need both these denominators to be the same, right? So I would need this to be 12. I need this to be 12. So I would multiply this by 3 over 3, and I multiply this by 4 over 4. Cool? These, so far, do not have the same denominator. However, we can try to factor this one to see if it can break down into like already having one of these, which it probably will. This should always be your first hint, Saint, when you see something like this, is that if I see an x minus 5 here, x minus 5 is probably a factor here. Your teacher's not like that, like mean. They're not gonna combine two fractions that don't at least share one common factor. So the first thing is to break this up, okay? Which I can break this up by like saying, okay, what multiplies to 20 but adds to -9? And I know that's that's -5 and -4. -5 times -4 is positive 20. And -5 minus 4 is -9. So this whole thing is going to be 2 over x minus 5 minus, and then it's 2 over x minus 5, x minus 4. Okay? Now, you see how they share a factor? I knew that was going to happen, right? I could kind of tell. I can guess. You know, when they write questions, they write them because they want to be kind of easy to do. The stream is laggy for you? Oh, okay. Well, I mean, there's going to be a difference in the audio. Yeah, there's like a couple seconds in the audio. Yeah, don't worry about that. It's, yeah. It looks okay, though. I know there's a latency, but I hope it's not like stuttering or anything. I think I fixed that today. It was something with my AMD card. Yeah. So yeah, if I want this to have the same denominator as this, that means this has to be x minus 4 over x minus 4, right? Because that will get me the same denominator as this. Okay? So multiplying this together, that's 2x minus 8 all over x minus 5, x minus 4, minus 2 over x minus 5, x minus 4, right? Okay? These both have the same denominator, so now you can combine them. So 2x minus 8 minus 2, the minus 8 and the minus 2 combine to give you 2x minus 10 over, again, x minus 5, x minus 4. Another thing that usually happens is this will now factor out to one of these things. So I notice I can pull a 2 out of both of these, right? So if I pull a 2 out, okay, now this becomes 2 times x minus 5. Yeah, good. As long as you can see me do it. Yeah. You type if like something doesn't make sense, and I'll go back and fix it. But yeah, now you have x minus 5 on the top, x minus 5 on the bottom. Goodbye. And you're just left with 2 over x minus 4. Yeah? Yeah, it's okay if you can't respond. As long as it makes sense. You just respond and stop me if it doesn't. Yeah. We'll get your audio fixed. Okay. This one multiplies to -3, adds up to -2. That's going to be +1 and -3. So I have 5 over x plus 1, x minus 3. This one's probably going to share one of those, and I think it does, right? This is multiplies to 1 is 1 and 1, adds up to 2, right? 1 and 1. So this is +3, x plus 1, x plus 1. Okay? Interesting. So this one will need an additional x plus 1. Right? So that they matchy-matchy over here. And then this one is going to need an x minus 3. So that they both match. Okay? Expand that out. Expand that out. Yeah, it's not that bad, right? Yeah, so this is just 5x plus 5 plus 3x minus 9 all over all this shit, right? X plus 1 squared, x minus 3. 5x plus 3x is 8x. So I get 8x. 5 minus 9 is minus 4 over x plus 1 squared, x minus 3. Even if I pull a 4 out of this is going to be like 2x minus 1. So none of things going to cancel. You can kind of just leave it like this. Yeah. And there you go. You're done. Nice.
That's dope.
Not as bad. Not as bad, he says. Nope. All right. Oh, God, dude. What is this? Let me see. Let me see if half alpha's here. I'll do halves. And then, yeah, Sozway, you're up. And then I think I probably got to run after that. Well, Taco Cat's still here. I got Taco Cat. Yeah, Taco. You got some good ones, Taco. I like your questions. I really do. Yeah, what's up, Twitch? Hope you guys are doing all right. It's Wednesday, right? Is it Wednesday? Yeah, halfway through the week. Equity says, are we doing Fortnite on Saturday? I don't think so, because...
That's dope.
Yeah, I'm going to be in Vegas, and I do think I kind of have to be present to run the Fortnite thing. I can't think of anyone that would run it, like, responsibly yet. But don't worry. I'll do, like, a doubleheader with you guys the next week. Or maybe we'll do something during the week? Nah, I got to kind of do the weekends, because you guys are only really free on the weekends. Okay, I'll wait for... Okay, whenever half alpha shows up, we'll do half alphas. Until then, Josue, you're up, dog. Here, let's get you up. What's up, dog? Oh, yeah, let me send the screenshot of this. Yeah, I can, Jose. How's it going on? How's your Wednesday going, dude?
Not too bad. Just studying all day.
Oh, because you got exams coming up, no? Right?
Yeah, I have an exam this Saturday.
Ooh, okay. Good luck, dude. All right, let's see. We got the integral of arctangent. Ew. I think you're supposed to
Yeah.
know these. Arctan. Let me get the stuff here. Yeah, okay, so the derivative of arctangent is 1 plus x squared. Let me just write that down, because we might need that. d dx of inverse tan is 1 over 1 plus x squared. I believe that's what that is, right? And I think that's the one I'm going to use, actually. I think we're going to use integration by parts. You want to see why? It's kind of cool.
Yeah, I know it's integration by parts. It's there's a little thing that confuses me is that once you get the integral after integration by parts, it's just like weird.
It's just weird? Okay. So, I don't really know how to do the integral of arctan. I don't. But I do know how to take the derivative of it, right? So, when I pick out my
Right,
u and my
yeah.
v, right, I'm going to say, okay, u is equal to arctan.
Right.
And so then du is equal to 1 over 1 plus x squared. And then that means that v is equal to x dx, and then, dv is equal to x dx. So v is equal to x squared over 2, right?
Mm-hmm.
Good. So integration by parts. So it's x squared over 2 tangent negative 1 of x, evaluated from 0 to 1, minus the integral from 0 to 1 of v du. So that's 1/2, and that's x squared over 1 plus x squared.
Mm.
Dx.
This is the part where I'm stuck.
I got you. I feel you, man. I think what I say is I say x is equal to tangent of x. Okay. So dx is equal to secant squared of x. Let's just see if this works. So now what I get when I replace this, right? I get tangent squared of x, secant squared of x, dx. Oh wait, sorry. I need to use different variables. I can't be saying x is tan x. X is tan u. Sorry, my bad. Okay, x is equal to tan u. So that's tangent squared of u, and then dx is now secant squared u du, right?
Mm-hmm.
Okay, and then this is 1 plus tangent squared of u. Do you know what 1 plus tangent squared of u is?
Secant squared.
Good.
U.
Yeah, so this goes away, right? So now this is secant squared of u. Cool. Okay, cool. This is going to go away, right?
Mm-hmm.
So now I just have 1/2. These bounds are wrong, right? Because it's 1/2. Oh, this is actually okay, right? Because, x was equal to tan u. Oh, so this is 0 to 1 of just x squared, right? Did I do that right? Seems very simple. One sec. What did we do here? Let x equal to tangent of u. Good. Yes, tangent squared u. So, yeah. Well, tangent squared, secant squared. So, yeah, dx is secant squared u du. Yeah. Okay. Yeah, and then I just replace it back, right? Tangent squared of u is just x squared, right? So now we can just do this integral, I guess? Is that right?
Do you have to do the triangle, the little to find u or something like that?
No, I don't think so. One sec. Am I crazy?
Beta.
One sec. Am I crazy, dude? I'm having a moment. I had this earlier today. I was at the gym, dude. I was like trying to count the weights on my barbell, and I was just not doing the math completely wrong. Okay, let's see what's happening here. They say it's x minus arctan of x. Oh, I think I know what I did wrong here. Okay, sorry. Oh, you know what? Okay, sorry, I'm fucking up, dude. So integral of tangent squared of u. Wait. What am I doing here, dude? What are you doing? X equals tangent of u. Yeah. So dx is secant squared u du. Okay. Oh, okay. Yeah. And then 1 plus tangent squared is secant squared, right? I'm right about that, I think, right? Yeah.
I think it's 1 minus. Right?
No, it's 1 plus tangent
Oh, no.
squared is secant
Okay.
squared. What am I doing wrong? What am I doing wrong? Oh, you know what I'm doing wrong here? U is okay, so U is equal to the arctangent of X. What am I doing? Okay, one sec. This street. Okay. Oh, those last problems you needed? Okay, cool. What am I doing wrong here? One sec. Let me just see the step-by-step solutions. They want to do polynomial long division. I don't want to do this. This sucks. No, dude. What? I guess it is possible. I'm confused why my trick doesn't work. Why can't I just say x is equal to tangent of u? So x squared is tangent squared of u. And then
If you make u as theta, can you also do like where you have to draw the triangle to solve for x?
yeah, but I don't need to, right? Because doesn't this just cancel like automatically, right? Because dx is just the derivative of tangent is secant squared. I'm pretty sure of that. Yeah, secant squared. Why does this not work? Tangent squared u, dx is secant squared u du. And then it's 1 plus tangent squared, which is just secant squared. Goes away, bang, bang, bang. And then it's 0 to 1 of... Oh, okay. Tangent squared u du. But I said that tangent of u is equal to x. Oh, I see why this doesn't work. My bad. Yeah, the issue is that when I sub back in for du, that doesn't work, right? Yeah. Because du is equal to dx over secant squared of u. So sorry. Yes, I could sub this back in for x squared, but then the issue is that then I have secant squared of u, which is bad. Can't do it. Okay, cool. All right, that's why. Okay, we're to here. Okay. This is where I think I wanted to, and ignore these bounds because they're not real yet. I think this is 1/2, and then this is sine squared u over cosine squared u du. Which I could do another u sub, I guess, right? I could say like v is equal to v is equal to cosine of u. So then dv is equal to negative sine of u du. Oh, but that's not going to cancel out all the things. Yeah, oh, that's a mess. Okay, maybe we do have to do it with polynomial long. Okay, yeah, yeah, my bad. Okay, this was a cool tangent. I thought we were there. I thought I saw it. It was snatched from the jaws of victory. I think you just have to do long division for this. Okay, so 1 plus x squared gets divided by x squared, right? So, let me put that in the right order. Right, x squared plus 1, x squared. Okay, so x squared goes into x squared just one time, right? And then that goes in 0 times. So you're left with, right, x squared over 1 plus x squared is now equal to 1, right, plus 1 over... No, sorry, I'm messing this up too. Sorry. Oh, my God. It's this. This is what it is. Okay, cool. Okay. This goes in 1 time, right? So then that's x squared plus 1. And this is plus 0, right? That becomes 0. And then what's left when we subtract this is negative 1. And this is now a remainder. So this whole thing, x squared over 1 plus x squared, is equal to 1 minus 1 over 1 plus x squared. Does that make sense? Have you done that with long division yet?
Yeah. My only question is like, why would the x squared go inside? Or wait, hold on.
Well, okay, so yeah, because if you do like 5 divided by 3, right? This is like 5 over 3.
Oh, okay.
Is that what you're wondering? Yeah, it's I did it wrong the first time. was
What
bad
the
of me.
top goes inside.
That's very bad. I did it
Or
so
the
bad the
numerator?
first time. Yes. The numerator goes inside, the denominator goes outside.
Oh, okay.
Yeah, it's okay. Yeah, I make mistakes too. So, yeah, once you divide that, you get, this is the remainder. Okay, and now it's the integral, right? This is easy. The integral, this is just fucking x. Great, cool. And then this is arctangent, right? Because remember, right, the derivative of arctangent was that, so the integral of that is just arctangent. So yeah, good. That's why you get x, and then it's minus the arctangent -1 of x. So your final answer is x squared inverse tangent of x from 0 to 1 minus 1/2, and then it's x minus the arctangent of x from 0 to 1. And then do you know how to figure out arctangent of 1, arctangent of 0?
It's just like the unit circle, right?
It is, yeah. So arctangent of 1 is like, what angle, when I take the tangent, do I get 1? Remember, tangent is opposite over adjacent. So when does the opposite equal the adjacent?
In the unit circle, right?
Yeah. We'll remember, right? Yeah. So tangent, right, is equal to opposite over adjacent. So inverse tangent of 1 is asking what angle, right? This is like equal to theta. I'm saying what angle when I take the tangent of it is the opposite over the adjacent equal to 1. This is how you understand like inverse trig functions. This is another good question. Do you understand? Like, this is commonly not really taught very well. Like, do you understand like what this means? Like,
I know it means like the opposite, right?
It's the inverse. So what I'm saying is, when I say arctan of 1, arctangent gives you an angle, right? Regular tangent gives you a number. It gives you a ratio, okay? So if I take the tangent of both sides here, okay? Tangent of inverse tangent, these things go away. And you're just left with 1 is equal to the tangent of theta. So now this sometimes makes more sense because you're like, okay, cool. My answer is whatever angle that when I take the tangent of it, I get 1. And I remember that the tangent is the opposite over the adjacent, okay? So that means I need the opposite to be equal to the adjacent for opposite over adjacent to equal 1. Does that make sense?
Yeah.
Where in the unit circle do I have the opposite and the adjacent equaling each other? I'm going to cheat and draw it for you. Do you remember here?
Yeah.
Do you know what angle that is? I'm going to give you a hint. Isosceles triangles. You see how this makes a triangle? And the opposite and the adjacent are the same? Like this is equal to this? What type of triangle is this?
A right triangle?
Well, it's a right triangle, definitely, yeah, okay. But if two of the sides are the same, that's called an isosceles triangle, right?
Right.
Do you know the angles of an isosceles triangle? It's okay if you don't.
No.
No? Okay. Here's another cool little... you know what the cool thing is here? We're going down a rabbit hole. This reminds me of like going down like a psychedelic trip of like, I'm like, okay, you don't know this? All right, let's go find this. Oh, you don't know this? Okay, let's go find this. Like, these are all... We're finding all the little bits of math that you really should know. But obviously you didn't get taught because like COVID fucking sucked. No one fucking learned shit. I get it. So
that was it.
So if it seems annoying, I'm trying to like correct these little things where I'm like, no, you need to know this, you need to know this, you need to know this. Like we have to flip all these light switches. Okay.
Yeah, and I also want to learn it too.
Good. No, I'm glad you want to learn it. That's dope. Yeah. Okay. So if I have a triangle, right, that has sides that are the same, okay. Let me move this over. What we say is that the ratio of the angles is also kind of the same as the ratio of the sides, okay? So if this side is equal to this side, that's what this means. The double lines mean the two sides are equal to each other. That means the angles opposite of them must also be the same. Maybe that's something you learn in geometry, okay? So if I know this angle, Josue, right, is 90 degrees, and what is the total angle of a triangle?
Total angle?
Yeah, what's the sum of the angles inside a triangle? It's okay if you don't know this one as well, because I'm going to tell you.
Something like 180, right?
Good, it's 180. Yes, it's
Okay.
180. Okay. I think the rule is, I think it's like n minus 2 times 180 for anything, for any. So the number of sides here, minus 2 times 180, is the sum of all the angles. That's why a square is 360. Triangle is 180. Those are the only real ones you have to know. Okay. All right. If the total is 180, and I know this is 90, and I know these two have to be the same, what are these angles going to be? Or what do they have to add up to?
I have to add up to 180.
Yeah, so you have like 90, right? Plus mystery equals 180. And I know these are the same.
Uh-huh.
So you see I can like move this over. This is where we do a little bit of algebra, right? So 2 times the mystery number
Right,
is equal to
yes.
90. So what's the mystery number?
Right. You divide 90 by 2.
Good, exactly.
Find the mystery.
And what's the mystery number? You got it.
I don't have my calculator with me.
You don't need your calculator for this. No. You know. What's 80 divided by 2?
40,
Good. What's 100 divided by 2?
50,
What's halfway in between 180? 180, sorry.
90,
Okay. What's halfway between 50 and 40?
10,
No. Halfway between 50 and 40. Like midway from 40 to 50. It's 45.
Oh.
Do you see that, right? Like halfway from 40 to 50 is 45. Like if I'm going like 40 miles an hour and someone's going 50 miles an hour, right in the middle would be 45.
Yeah.
That's how I know that 90 over 2 is equal to 45. I mean, I just know because like I've been teaching math for fucking ever, but like this is another way to kind of see it. Is if I know what something
That's
is,
a new trick. Yeah, I haven't seen
you like, yeah, this is a cool trick. Yeah. All right, yeah. So good, yeah. So this is 45 degrees. And again, these are the two, there's like 2 important triangles you have to know in life to do anything with the unit circle. And it's the 30, 60, 90, right? And then it's the 45, 45, 90. You probably learned these at some point. Yeah. This is not the scale. Don't murder me.
Yeah.
Yeah. And then what you learn is this is 1. This is square root of 2 over 2. This is square root of 2 over 2. And then this one is 1. This is 1/2. And then this is the square root of 3 over 2. Notice how the bigger side, square root of 3 over 2, is opposite the bigger angle. And 1/2, which is smaller than square root of 3/2, is opposite the smaller angle. That's kind of the trick I was showing you when I said, like, hey, look, if these angles are the same, the sides have to be the same. Right?
Oh, okay.
Yeah, that's where it comes from. Okay, so after all of this, right? Okay, so here we go back here. All right. Arctangent of 1 is then 45 degrees, right? Because that's where the opposite and the adjacent equal each other, right? Opposite and adjacent equal each other at 45 degrees. However, your teacher is not going to let you use degrees. You got to put things in radians. And I'll save that for another time, but that's just pi over 4. You just know that. Pi over 4. Okay?
Yeah.
So this becomes, when I plug it in 1, right? It's 1 squared pi over 4 minus 0. I don't care about what the fuck this is. 0, right? Cool. Minus 1/2. Okay? Then we're going to put in 1 again, right? So this is going to be 1 minus pi over 4, right? And then it's minus, plug it again for 0. That goes to 0. And then also the arctangent of 0 is 0. Because that's where the opposite is 0. And the opposite, which is this side, that is 0 once the angle goes down to 0, is what it is. If you, like, are you, like, scared of, I was always, like, fucking deathly scared of the unit circle. I fucking hate the unit circle. Like, I hate that they make you memorize it, right? Have you seen my, like, quick TikTok video I have on, like, why the unit circle is what it is and, like, an easier way to, like, know it?
Nah.
Okay. Do you like TikTok?
You have a reel on it?
Yeah, I have a whole fucking reel on. I have reels on fucking everything. But yes, here you go, Josue.
Oh, okay, yeah.
Go watch that. This TikTok shows you the two triangles we talked about and how you can use them to calculate any trig identity without having to memorize that dumb as fuck circle. Like, you don't have to. And then I have another one which is like when we do like tangent, and then I talk about like what happens when we're in the other quadrants. And so there's a whole series here of videos. Feel free to go through there. I have other stuff on derivatives. A lot of this is a lot of calculus related rates. Here, U-sub, Rolle's theorem, IBT, asymptotes, dot products. I don't know. What was the most recent thing I did? Yeah, F prime graph from F prime. The double chain rule. This is another one that like people always get confused with. So, yes, if you like TikTok instead of like scrolling through dumb things, go watch the math. It's kind of cool. Anyways, but that's why this is all 0. So then your final answer is pi over 4 minus 1/2 1 minus pi over 4. And you should be done. Yeah.
Interesting.
Does that make more sense? There's a lot there. There's a lot
Yeah.
we did.
Yeah.
Find the y coordinate of the y prime of the centroid of the region above the line y equals 1. Dude, Jesus, what type of question is this? I don't know if I have time for this one because I do got to run pretty soon.
It is pretty long. It's talking about more like the center of mass.
Yeah. How does that?
And then finding like the point in the region or something like that.
Yeah, it's well. Hello, I'm here for education. Hi, Casey. Good to see you. Yes, Casey. Well, unfortunately, I have to leave pretty soon, Casey, so I can't educate you too much more today. But yes, later. Let me see. Let me just here. I'll give you the solution to this. Go through it, and if it's difficult, or maybe I can just like explain it real quick. For me to figure it out with the equations right now would take too much time. Like I could teach it, but what's up, Sensation? Good to see you, dude. Dang it! Not overcome my fear of math. Well, please, hey Casey, we stream 3 times a week. There's our schedule. You just happen to find us right at the time that we're leaving at. Region above the line y equals 1 and curve. Well, that's visually. Ugh. They don't actually do it. Someone hasn't done this yet. I think there's like an integral form for this one. How does it work? Aha! Yes, that's dA, but then what's the... Oh, okay. Total area of the shape. Sorry, I'm kind of just seeing what they do here.
I know, man.
Hey, what's up? What's up, dude? What's up? Integral of dA, the equation describing the width of the shape. Oh, okay, this is kind of cool. Okay. So the centroid, right? You're going from 1 to 2. Do you see this? Y min to Y max? Josue?
Yeah.
Okay. And then it's the width of the shape at any. So that's the width of this, right? Which is that's equal to the x. That's 2 times the x value, right? Whatever the x value is here, right? So if I solve for that, right, I get y squared is equal to 4 minus x squared, right? So x is equal to the square root of y squared minus 4, right? No, I fucked that up. Sorry, is equal to 4 minus y squared. Does that make sense? I squared both sides. Yeah. Okay, cool. So that's what this. So it's the integral, right? From 1 to 2 of square root of 4 minus y squared times 2, right? Because that's only one of the widths, right? We need the whole width, okay? And then that's times y. Times y? Is that really? Yeah, I guess times y. Okay, yeah, times y. Okay. dy, right?
Mm-hmm.
All over, and then the total area of the shape, which is this. It's this without the y term. So now it's 1 to 2 square root of 2 4 minus y squared dy. Okay? This becomes a nice just chain rule, right? Because you see this is a nice u sub because I have y squared and I have y on the outside. So that's cool, right? Because the derivative of this will just show up here. This, I believe, is an arcsecant question. It's a little harder. Yeah. That comes from trig integral identities. It's this. It's trig substitution, I think is what it is. Trig substitution integrals has to do with this. Yeah.
Okay.
Yeah, so there you go. So whenever you have whenever you have, for instance, the square root of a number minus x squared, this is the substitution you want to make. So you're going to want to call this thing, I think, like 2 cos. I think you're going to say y is equal to
Y equals like
2 cosine theta is what you're going to want to do for this one. And then this one you just say u is equal to 4 minus y squared, so du is equal to negative 2y dy, which is cool because that 2y actually pops out, which is nice. It's a nice integral. Cool. I'll leave that for you to actually solve it, but that's how you set it up.
I've got a question.
Yeah.
About this.
What's your question? What's your question, Sensation, dude? What's up, Doug?
Well, square root of 9 minus y squared can't
Yes.
be resolved, but the square root of 4 minus y squared can be, so why leave it like that?
Square root of 9 minus y squared can't be resolved. No. What do you mean?
Was it, where it says integration by trigonometric substitution.
Oh,
square root
here.
Of, 9
this?
minus x squared can't be resolved, but the square root of 4 minus y squared can be.
It can't. No, they both can be. You just have to change what this is for the a value. That's all you have to do. So here,
Okay.
yeah, all they do is they just change what theta is. Yeah, that's all they do. Where the fuck was the other thing? And then Josue, here's the other one we had. Yeah. What time is it for you, Sensation, dude? Must be kind of late, no?
I've just got up, so it's
Hey,
half past two.
just got up, dude. You're nuts, dude, bro. What? Oh my god. All right, Josue, I hope that helps you out. Good luck on your exam. I sent you the screenshots. Feel free, dude. If you need extra help, you can always post things in here. And if I have free time during the week, I may just like write up a solution for you. If I have time.
Right.
Or someone
I was
else
also
with.
thinking, like, going to the
What's up?
going to the other streamers that do the math.
Yes, please check them out. You have all their links, right? If we just I'll do X math streamers. Yeah, totally. Find out when they're streaming. Sometimes they're doing a gaming stream, and sometimes they're doing like a real analysis stream. So just whenever they stream, see what type of stream they're doing. A lot of times they will be answering questions from viewers. That's a great opportunity for you to go get help with them. Yeah, please do, and tell them I sent you so that like they know that I'm trying to like put this kind of like conglomerate together of like getting everyone to just help. So yeah, awesome.
Mhm.
Love it, dude. Okay, cool. Good luck, Josue.
Thank you.
You're welcome.
Yep.
Taco, where are you at, Taco? I really gotta run, Taco, so I gotta do this real quick for you, dog. Real fucking quick. And I gotta give Josue his point. Give Josue his point. And then where was Half Alpha today? We didn't see Half Alpha. Casey Snowart, how'd you find us, Casey? What's up? How'd you find us, Case? Curious. Also, yeah, join our Discord if you haven't yet, Casey. That's the best way to find out when we stream and everything. All right, I will give like 2 minutes, and then I gotta run. Really gotta run. All right, cool. I don't see anyone. Let's head out. All right, thanks everyone for coming to office hours today. Had a super fun time answering all your math questions. Please, if you haven't joined our Discord, there's our link and everything. That'll tell you the next time we're streaming. Quick announcements. We have an awesome, very special guest tomorrow for the AMA. I usually run the AMA on Friday, but I got to go to Vegas. So Thursday, we're going to be doing the AMA. It's an hour later, and we're doing it with my really, really good friend. Her name is Jess, and she's a therapist, and she's awesome. So if you have any mental health type questions, please, like, ask them. This is the time to ask them. If you want them to remain anonymous, so, like, I understand, like, asking mental health questions is sometimes kind of, like, taboo. Like, even though you guys have usernames and stuff, like, that still has a reputation to it, I guess. So, if you want to ask them anonymously, here, I'm going to put the link. There's the link. There it is. Okay, cool. Yes. And so what you can do is you can ask a question right here for Jess to discuss during the stream. So if you want to, so we do a thing where we give out a prize to the best question that gets asked. So if you win the prize and you want to claim that, like, oh, that was my question, just create like some 6-digit code so that you can tell me later, like, oh, hey, that was my question. Here was my code, and then I can make sure you get points for it. But otherwise, yeah, please use this opportunity. Therapists are fucking expensive, and so I got one to be here for free for you guys on the podcast. So let's talk about mental health and stuff. Yeah, love it. Okay. Anyways, all right. Awesome. Okay, let's go back. Here, go say hi to my girl, Moo Hoodles. She's super cool. She does, like, space stuff. Wait, has her stream actually started yet? One sec. I don't think her stream is starting. One sec. I would like for her stream to be starting. When did she start? Oh, she starts in 4 minutes. Okay, that's going to take too much time. Is Danny doing math questions? Danny is. Okay, we're going to go raid Danny. We love Danny. Here, go say hi to Danny for me. If you need more help with math, Danny is the guy who also tutors and does a lot of cool math stuff. So, no, you're good. You're good for lurking, Casey. Yeah, I just wanted to say hi to you because you met us. If you want to learn more math, we're going to be raiding Danny, and he's another great streamer who helps out with math stuff and can answer some questions. So please go ask Danny some questions. Go say hi to him from me. And I will see you guys on tomorrow's AMA podcast. Cool? All right.
That's dope.
Peace out.